So very specifically, we're looking at uncertainty and measurement. And it's basically a way of showing people who are reading your experiment or your data how precise your measurements are. And it's not an overly difficult thing to get your head around. It does take a bit of practice. Okay. So to do this, we take our smallest measurement increment and divide it by 2. And there's a reason why we do that. And rather than try and explain it with words and heaps of text, I thought I'd just show you a couple of examples, something you could help me with. So on the board, I've got a centimetre ruler and a millimetre ruler. It doesn't matter about where they start, it's just a section of the ruler. Happy with that? We're assuming this goes all the way back to 0, doesn't matter. How long is that, let's just call it a candy cane. How long is that candy cane? 4 centimetres. A little bit more than 4, about 4. Happy with that? So if I was writing my report and I wanted to write that, I could say 4, I might just go 4.0 centimetres plus or minus 0.5 centimetres. And what I'm saying is that that candy cane falls inside that range there. Are we happy with that? Now, we can probably say, well, that's pretty safely not the case, isn't it? It's probably closer to 4.1 than it is to 3.5. Happy with that? But that's because it's a really big increment. If we were to go down to this increment here, so I want you to, in your books, write down what you think I would write there. Before I give you the answer, I want you to spend, I'm going to give you 10 seconds now to write down how long you think that red candy cane is. That's centimetres again, same unit. In your book. Give you a hint, the first number's 1, followed by a decimal place. There you are. And you need a plus or minus something. 10 seconds. 5. All right. I'll give you another hint. Your next number should be 2. What do you think? Got 3s? Who thinks 3? Who thinks 4? Who thinks 5? Who thinks 6? Most people didn't have an opinion. I think 1.25 plus or minus. What should I write here? 0.5? 0.05. So you're saying that goes between there and somewhere down here? That's a fair? 0.05. So by taking half of our smallest increment, what we're saying is it must lie, so we've said it here, it must lie between here and here. Now if you look at your ruler and you try and measure to the nearest millimetre, that gets pretty tricky, correct? So this seems pretty extreme when it's zoomed up on the board. But when you're doing it in reality, like measure the length of your pencil with uncertainty. Find a ruler on your table, measure the length of your pencil or your calculator or your glue stick, I don't care. Measure the length of something with your ruler and provide an uncertainty. And you'll see that the uncertainty
You do not want you are not.